So today we are going to wrap up our coverage of normalization. In fact, we're wrapping up our coverage of design. And I'm going to finish where I left off on Tuesday. So on Tuesday I was talking about how to go from first normal form to second normal form. And then I have a case study where actually what I'm going to do is have you read the case study, try to answer the question for a few minutes, then I'll answer the question, then we'll move on. It's a former exam question or homework question. I forget which of the two it is, but at any rate, I found it's helpful to work through it. So first, just a very quick review. Remember, normalization is a design method. It is a bottom-up design method, and it is more of a mathematical approach to designing or decomposing relations. And when we do normalization, we're trying to preserve, we're decomposing a relation into smaller relations. And what we're trying to do is preserve two properties. One is called a lossless join. When we decompose a relation into two or more subrelations, we should be able to join those subrelations back together and obtain the original relation without losing any information. And the way we do that is with foreign keys. So we call that the lossless join property. And the second property we want to preserve is dependency. So we have these dependencies between attributes. And last time we then went ahead and said what these are functional dependencies. And when we decompose the relation into subrelations, we want to make sure that each functional dependency is preserved in one of the subrelations. So that's the second important property that we need to preserve. And after defining what a functional dependency was, which is essentially what you would expect for a function that the attributes on the left side uniquely determine it on the right side, we then started talking about the actual process of normalization itself. And it proceeds through a number of steps from what we call unnormalized form up to whatever normal form we're shooting for. In this course, that is third normal form. So the unnormalized form is not even considered a relation because the cell may have a multi-valued attribute. So the way we go from an unnormalized normal form to first normal form is that we basically somehow remove multi-valued attributes from a cell. And that means we either make enough columns to handle the maximum number of values for that attribute, which I said is not something I want you to do. The second way is better. We put that multi-valued attribute into a separate relation. So when we're done with first normal form, what we have is one value per cell, exactly one value per cell. So that's first normal form. Then we want to go to second normal form, and that's where we finished up last time. And what we want to do when we go from first normal form to second normal form is eliminate what we call partial dependencies on the primary key. And what that means is that any attributes that are left in a relation when we're done in second normal form are fully functionally dependent on the primary key. They're not fully functionally dependent on some subset of the primary key. So as an example, first of all, you have to identify the primary key. And one important thing is that if the primary key is a single attribute, then you already are in second normal form. I think I said that last time, but I'll just write that down again because I think it's really important. So if you are in first normal form, or if a relation, so I shouldn't say if a relation is, so if a relation is in first normal form and the primary key is a single attribute, then the relation is also in second normal form. At least on the primary key. And the reason is that when you eliminate partial dependencies are on a subset of the primary key. Well, if you have on a proper subset. So if you have a single attribute, you can't have a proper subset that is not zero. Okay, so second normal form only comes into play when we have a primary key that has multiple attributes. So of course, I chose an example that had multiple attributes for the primary key. The example was a lease agreement. The book calls it a client-rental relation, but what it really is a lease. And we went through these relationships last time and decided that the client number, or I decided that the client number and the property number would be the primary key. So if we're going to break this relation is in first normal form, we want to convert it to second normal form. There's two partial dependencies. There's one from the client number to the client name, and there's a second property number determining the property address, the rent, the owner number, and transitively through the owner number determining the owner name. So we say that these two right here, this one and this one, are partial dependencies because their left-hand attributes are a subset of the primary key. We good with that? Okay. So what happens when we go from first to second normal form is that for each partial dependency, so this was one of the two partial dependencies, this property number, we take all the attributes in that partial dependency, both the left-hand side and the right-hand side, and we take all of those attributes and put them in a new relation. So for example, we might name this new relation the property relation. And we remove from the original relation the right-hand side attributes. So I don't think I have that down. I kind of, but I didn't say it. So I said, and remove P address, rent, owner number, and owner name from client rental. So I could have been a little, that was a specific example, so I could say in general. So actually let me put a new slide in here. So first normal form to second normal form. Okay, so in general, the right-hand side attributes are deleted from the original relation and are moved to the new relation. Okay? The left-hand side attributes, the determinant, both remain in the original relation and are copied to the new relation. Okay, and so the left, I'm just going to abbreviate LHS attributes, become what we call the what? Foreign key, actually. Become the foreign key in the new relation. So that's what preserves the lossless join property. Okay, so this preserves the lossless join property. So that's the general rule for what you do when you go from first to second normal form. So in general, for each partial dependency, so I'll say in general, okay, for each partial dependency, the right-hand side attributes are deleted from the original relation, they move to a new relation. And the left-hand side attributes, which are the determinant for that partial dependency, they both stay in the original relation and they show up in the new relation as well. Okay? And this also preserves the functional dependency because all the attributes in the functional dependency move as well. So I'm going to say this also preserves the preserves the dependency because all attributes in the dependency are in the new relation. Okay, so it preserves both of the properties. Questions about that? Okay, so basically when we're done transforming that original lease into second normal form, we're going to end up with 3 new relations. So the dependency with the property number, that moves into 1 new relation. The dependency involving the client number creates a second new relation. And then what's left, I called it rental, you could call it lease, is whatever information was fully functionally dependent on just the primary key. So the only 2 properties that depended only on the primary key was rent start and rent finish. So that's all that's left in the original relation. Also, what's important in second normal form is that any attributes involved in a transitive dependency move. So owner name didn't directly depend on property number. It depended on owner number. But when owner number moved to a new relation, then owner name had to tag along. So it's important that you also move any attributes involved in a transitive dependency to the new relation.
So it was already given that, let's say, for property on that rent was a part of, I believe, I don't know if you said that the rent was a part of property number.
Let's see. Rent was, yes, determined by the property. Let's see. Did I put rent start and rent finish? Okay. Yes. This is, honestly, you could make an argument that rent really should go in the lease, not in the, right? Because the rent is not fixed for all time. So you could make a very good argument that the rent should go in the lease, but I didn't. I just said assume for the purposes of this problem that the property number determines the rent.
So if we out in the real world, we see just some relation, and we're going to make these new relations based on the properties. It'll be up to us or whoever I guess over us to pick and choose which relations are dependent.
Yes, that's right. So that's part of that interview process where you have to talk to people and kind of figure out, okay, what determines the rent, okay? So usually, okay, in the real world, it would get a little messier. So in the real world, probably at any given time, the property relation really does reflect the rent we're charging for that property as of that day. But we probably have multiple leases for that property. And some of those leases are historical. And those leases probably have different rental rates for that property. So in reality, probably you would have you might have a second relation, which is like past or lapsed leases. And those lapsed leases would probably have a rent field that described what was the rent for that lease during that lease. That's what I mean by messier. So in this class, I try to keep it a little less messy by, okay, I'm definitely simplifying.
Oh, yeah, yeah.
Okay.
Does it
Yes.
sometimes make sense to make like a stable relationship not normalized because of performance? Then you'll just generate a bunch more joins to be normalized?
Yep, it does.
Trade-off of
So some of those, usually at this level, up to third normal form, it usually is advantageous to do the decomposition. Above third normal form, you start to get those trade-offs. Okay, so above the ones we're not talking about that would go into a graduate course, then you start getting into these trade-offs of, is it worth decomposing it, or is the cost of the joins make it such that we're willing to deal with making sure we don't have any update anomalies by being really careful with how we update the data. So you're absolutely right, but that usually starts to occur above third normal form, okay? So usually it's pretty well agreed that you should at least take your relations into third normal form. And after that, it's debatable. Okay, and you'd probably get experts, could get a lively debate about it, okay? So, other questions? Okay, so let's actually talk about how you now get to third normal form. And in third normal form, what we are doing, so we're going from second normal form to third normal form. So we always do this in steps. We don't jump from first normal form to third normal form. We first go from unnormalized form to first normal form. Then we go from first normal form to second normal form. Then from second to third. When we go from second to third normal form, we are eliminating transitive dependencies. So any set of attributes involved in a transitive dependency, those attributes are copied off into a new relation. And it's the same principle that I just outlined for partial dependencies, which is just replace partial with the word transitive here. So for each transitive dependency, when we go from second to third normal form, the right-hand side attributes get moved off to the new relation, and the determinant, the left-hand side, both stays in the old relation and is copied to the new relation, thus becoming the foreign key in the new relation. And because we copy all the attributes in our dependency into the new relation, we preserve that transitive dependency. Okay, so it is, in this case, we have one transitive dependency. It is the owner number determines the owner name. So when we go to third normal form, you're going to see that owner name is off in its own relation with owner number. Owner number is both in the new relation plus it remains in the old relation so that we can preserve the lossless join. Okay? So it is, once you have your functional dependencies in your primary key, it's a pretty straightforward process to do your decomposition. Now, one important thing. I chose as my primary key client number and property number. I could have chosen two other keys as the primary key down here. And if I had chosen a different key as the primary key, I would have ended up with the same third normal form relations. But I would not have ended up with the same second normal form relations because the primary key, let's say I chose this, how come I can't, my arrow goes, there we go. So let's say I chose this candidate key where it was client number and rent start determining the, being the primary key. If that were the case, it would turn out that what would be the partial dependency if the primary key was client number and rent start? So I'm making client number and rent start be the primary key. What is the partial dependency I use to go to second normal form? There's nothing on rent start, correct? What about on client number? There you go. Client number determines client name. So in this case, the dependency client number determines client name would be used to go from first to second normal form. But with client number and rent start as your primary key, this second dependency up here, property number determining all these other things, becomes a transitive dependency in this case and would be used for doing a transformation from second normal form to third normal form. Okay, so depending on what your primary key is, a dependency might be either a partial dependency or a transitive dependency. Okay, so the bottom line is generally you'll end up with the same set of third normal form relations, but you won't necessarily end up with the same set of second normal form relations. It's like all roads lead to Rome, but they might lead through different cities before they get to Rome. Okay, they lead to different second normal form cities. Okay, so that's it pretty much for doing our decomposition. When you're doing normalization as your primary design technique, you normally start by putting all of your attributes into one huge relation. What you were talking about is called the universal relation. So all your attributes for all entities go into this enormous relation called the universal relation. And then you establish your functional dependencies and you decompose that enormous universal relation into smaller relations. Okay? And just going back to what we talked about last time, generally with normalization, when you're done, every entity will be in a relation by itself. If you have two entities in the same relation, then you will have insert and then delete anomalies. Okay? And then, just broadly speaking, you also are trying to put attributes involved in relationships into separate relations, and that's to prevent update anomalies. Okay? You don't want to repeat that relationship more than once. Okay, now, what I have been talking about thus far is called primary key normalization, which is that we are normalizing based on the primary key only. There is a more general form of normalization where we not only eliminate partial dependencies on the primary key, but we also eliminate any partial dependencies on candidate keys to get to second normal form. And the same thing with third normal form, and that is that, well, that's the same actually. The general, it's really second normal form that differs when we say general second normal form, we're talking about eliminating any partial dependency on any candidate key. When we talk about primary key second normal form, we're only eliminating partial dependencies on the primary key. And I have the perfect example coming back here. When I chose the primary key to be the candidate the client number and the rent start, the only partial dependency on the primary key was this one. Client number determines client name. But if I was doing general form normalization, I would still have included the second dependency here as a partial dependency because it is part of a candidate key, namely client number and property number. So that's the difference between primary key normalization and general normalization. On the homework and on the exams, you're doing primary key normalization. So you're always just considering partial dependencies on the primary key. Okay. If you do general form normalization, then it turns out that all second normal forms are the same, as well as all third normal forms. If you're doing primary key normalization, then you end up with basically second normal forms can differ, but third normal forms should be the same. We good with that? We ready for a exercise? Okay. So, you can either look at this on the screen or you can squint at the, if you go to the lecture notes for today, there's something called the hotel case study. And so you can either try to squint at the display, I'll make it as big as possible, or you can go on your computer. Just take a couple minutes to read this and try to answer the first question, which is give an example of the following types of anomalies. So you have this big universal relation, which to make it easier, it's essentially a booking relation for a hotel chain. So it contains reservations. So call it a reservation relation. And what you need to do is give examples of the following types of anomalies, which means you kind of first have to identify the primary key. So just remember, also a quick thing. Remember, insert and delete anomalies refer to entities. Update anomalies refer to specific attributes. And feel free, to talk about it with a friend or neighbor. Okay. So let's start with insert anomalies. Can someone give me an example of an insert anomaly? Remember, it's going to involve an entity. Yes.
Try to insert a hotel, you'll have to give them like a guess and everything.
Very good. So if you try to insert a hotel, then the problem is you have to have a guest associated with the hotel. So basically, if you're thinking about what are the probable primary keys, one is probably going to be the guest number and the date from, either the date from or the date to. Because you can't have a overlapping reservation, so the guest number and the date from should somehow uniquely determine it. The other one that's going to uniquely determine it is the hotel number, the room number, and the date from, and that's because you can't have a double booked room. So the problem, if you try to insert a new hotel, is you need a guest. Very good. Same thing with room. If you try to insert a new room, you also have to have a guest number. So you might try to insert a new room in a hotel. Maybe we're expanding. And you can't do that unless you have a guest number. Okay. There is a third one that's a little more subtle here. Okay, it depends if the guest number is the primary key, there's no insert anomaly, okay, on guess. But if you make the primary key be the hotel number, the room number, and the date from, now guest becomes a insert anomaly, because now you can't insert a guest into the relation unless the guest has a booking. If the guest just wants to sign up for your frequent, or for your not frequent flyer, what would be the frequent guest? There we go. So at any rate, if you join their club, you couldn't actually join without a reservation. So that would be a third insert anomaly that would occur if the hotel number, room number, and date from were used as the primary key. Now, remember that delete anomalies are just a mere reflection of an insert anomaly. Every time you have an insert anomaly, you have a corresponding delete anomaly, always. So if you have an insert anomaly for a hotel, you also have a delete anomaly for that hotel. Okay, so the issue is if you remove all the reservations associated with that hotel, you will lose all information about that hotel, and you will lose all information. Similarly, if you remove all information about the room in a hotel, if you remove all reservations for a particular room in a hotel, you will lose all information about that room. Okay? So anytime you identify an insert anomaly, you have also identified a delete anomaly. Okay? Now, let's tackle update anomalies. Yes?
If you had to change the room number, then you also have to go back and change the room type and price.
So that is correct, but here is so you just said it in the reverse way, okay? If you change either the room type or the price, you're going to have to change that room type and room price for every instance of that room number, okay? you can't, room number turns out to be a key. You can't have an update anomaly on a key, okay, because there's no way to avoid redundancy on the key. You're absolutely right. If you change room number 635 to be 640, you have to change it everywhere, but there's no way to avoid redundancy on a key. So you can't have an update anomaly on the, here's the way to say it. If you have a functional dependency, and you do have a functional dependency of room number, actually hotel number and room number determines room type and room price, you can't have an update anomaly on the determinant, the left-hand side. You can have an anomaly on the right-hand side attributes. That's the best way for me to say it. So that's one. You got one. The room type and room price can have update anomalies because if you change either of them, you have to update every other instance of them in the database. Okay, we got two more. Yes, man in red. Pardon? If the guest city changes, or actually the guest name or guest zip. So if anything associated with a guest changes, then you have to update all other instances of that guest. So if it's the guest city, the guest name, if I call in and say, look, you bozos, you can't spell Vanderzanden, I'm tired of always having to tell you that my last name is Zanden and not Vanderzanden, would you please get it updated? Then they'd have to update it everywhere in the database. Okay, we have one more. Yes. If you change the hotel name or the hotel city or the hotel zip. So if you change any piece of information associated with the hotel, other than hotel number, because hotel number is part of the key.
So is the rule for that pretty much like change something that's not a primary key in another table?
Yes. If you change anything that is not probably part of a primary key in some table. So, or another way to think about it is if you change anything that would not be associated with the primary key for that entity. Okay, because that's the same way of saying it, Bentley, because every entity is going to end up in its own table. So basically, if you change any attribute that depends on the primary key of a entity, that's an update anomaly.
I had a question.
Mhm.
Can you go to the insert when we change the, you said the hotel name will be an anomaly? Can you explain that?
Okay, you're saying what if?
On the update, somebody said something about the hotel name. I mean, not update, but on insert.
Insert, I think what I said is if I change the primary key from guest number to hotel number and room number. So there's two different primary keys I can actually use for a reservation. Okay, one of them I can use the guest number and the date as the primary key because guests cannot have overlapping reservations. I can also use the hotel number, the room number, and the date because rooms can't be double booked. Okay, so if I choose, what I said was if I choose the primary key to be the hotel number, the room, and the room number, now guest becomes an insert anomaly because I can no longer insert a guest unless I have a reservation for that guest. And then conversely, if I make the primary key be guest number and room start, now I have two insert anomalies, one for hotel and one for room. I guess what I'm saying is I can't eliminate my, I have two different primary keys and my insert anomaly, the type of insert anomaly I have will depend on my primary key. Okay? So if the primary key is based off the guest number, I have two insert anomalies, one for hotel and one for room. If I say, okay, that's bad, I'll make the primary key be the hotel number and the room number, then I say, oh, that's no good because now the guest is the insert anomaly. So I'm like being argumentative.
Okay.
But the point is you can't avoid an insert anomaly. is basically you can't, by changing primary keys, avoid an insert anomaly. You simply change them. Okay? And then by definition, you correspondingly change the delete ones. Okay, here's the hard one, the one that always gets people on the exams. What are the functional dependencies for this relation? If you have a scrap piece of paper, try to write it down on a scrap piece of paper. If you have a computer in front of you, don't just try to think about it, because if it's in your brain, it's fuzzy. I would actually like you to do something where you actually try to enter things like A, B in your computer, because that will force you, in a little editor, because that will force you to quantify it, because that's what I would force you to do on the test. On a test, I would force you to say things like A determines B and C, maybe C determines D. So give it a try now, because guess what? You'll have to do it on a test. Okay, so what are the functional dependencies? Guess what? You derive the functional dependencies from these 6 assumptions up there. I'll give you another big hit. Pretty much every one of those defines a functional dependency. Each of those 6 pretty much defines a functional dependency. And it's fine to talk with the neighbor. Okay. I know you may not have quite finished, but I'm going to go over them because I have 15 minutes and I'm running on a schedule. It's like keeping the trains on schedule. Okay. And I'm actually going to go over the functional dependencies because I need to do them in 5 minutes so I can have you do your last part of this exercise. So each of these 6 points leads to a functional dependency. So in A, we say that a hotel number, which I'll abbreviate hotel number, identifies a hotel name and a zip code. So it's a pretty direct functional dependency. In B, it says a zip code uniquely identifies a city for both hotels and guests. So I could have said, if you look back here, you actually see hotel zip and you see guest zip. So I could certainly simply write that it actually determines hotel zip. And then down here under B, I could write that hotel zip uniquely determines a hotel city. And I could also write that a guest zip uniquely determines a guest city, like that. Nothing quite wrong with that. Just a second, Bentley. Before I answer your question, I might answer it. There's a problem, however, if you do it this way, that could result in your final database. Anyone see if I explicitly write the relationships exactly like this, what problem might I run into? It's going to result in 2 relations probably, right? Is there a problem with duplication perhaps? The same, like if I have the Knoxville zips 37920 or 37996, I'm going to have to put it in both of the databases and they're going to refer to the same city. So this is a case where ideally you would realize that this was happening and you just create a more general one where you might say zip code determines city, so that you end up expressing that functional dependency once rather than twice, so that in your final database you really only want 1 zip code relation. You really don't want 2. Bentley, did I answer your question or was it a different one?
It was, I had the wrong answer.
Okay. So I would, on a test, I wouldn't have marked you off for having 2 separate functional dependencies, one for guest zip code determines guest city and one for hotel zip code determines hotel city, but ideally you would just write it once. Okay, then guest number on part C. So point C says a guest number uniquely identifies a guest name and a zip code. Now, that's right, so it does determine a zip code. And I'm going to back here say that this is now zip code so that I'm good with all my attributes. Yes?
We did that with the generalization of zip code, but we also do it with number for hotels and guests. A number determines a name and a zip code.
Hotel number, what do you, no, because those are 2 different entities. I see what you're saying. You really do now, so a zip code is really the same thing, but a hotel and a guest are 2 different things. You really need a hotel database for your hotels and a guest database for your guests.
It's like a guest number and a room number doesn't determine the room type of price, but a hotel number and a room number determines the room type.
Right. So there's things that we'll get to in a moment. You'll see. Okay. So on part D, we have a room number and a hotel number uniquely determine a a room type and a price. Okay. If you're trying to say, though, I think what Bentley was saying was, if you try to say hotel number and guest number can somehow be combined, it's not the case that a room number and a guest number determines the room type and the room price, because a guest can stay at different rooms.
Could you put room type and room price just for hotel number?
No, because okay, so the question was, could I just do this? Could I just say that a hotel number determines a room type and a room price, but a hotel could have multiple rooms with different types. Like most hotels have a king size, and they have some doubles, they might have some queens, they might have the penthouse suite, that's where I roll. Oh, wait. So, but no, that's why you can't just say hotel number. You also have to say room number because there could be different room types and different prices. Okay, then E, now we get E and F are the interesting ones. Haha. When an instructor says interesting, means difficult. Okay, not obvious. So E, a guest may not have overlapping reservations. What that means, if you think about it, is a guest number and a start from, I think it's start, date from, is going to determine the date to. It's going to determine the hotel number and the room number that they're staying at. Now it's going to determine some other things as well. It's going to determine the room type, the room price. But why don't I include room type and room price here? Because room number and hotel number, so these two attributes together determine these. So if we already can determine attributes from attributes on the right-hand side, i.e. a transitive dependency, we don't list those attributes on the right-hand side. So guest number and date from directly determine only these three. Now, this is where it gets a little tricky on a test. This isn't the only functional dependency that you can get from E. A guest may not have overlapping reservations. Can you think of the other functional dependency I can get from E? Not allowed to have overlapping reservations. Very good. So the guest number and the date to determines the date from. Okay, it doesn't matter whether I know the beginning or the end. Each of them is uniquely determining the reservation because they can't overlap. Does that make sense? Okay, so we're moving on to F. So now we want a room may not be double booked. So we could start with room number, but that doesn't uniquely determine a room. What's required to uniquely determine a room, and it's more than just a room number? Hotel number. So we need both a hotel number and a room number. So a room may not be double booked, and it's the same thing. It means that if we know the booking date, the beginning date the room is booked, we must know the ending date. And what else do we know? The guest that is staying there. And again, we don't put in any of the other attributes because they can all be derived from the guest or from the hotel number and the room number. And just like the previous one, it doesn't matter whether we start from the beginning date or the ending date. So the other functional dependency in F is that if we know the ending date for the reservation, then we know the beginning, we know the beginning date and the guest. So those are the functional dependencies that we have. Okay, questions about that? We good? Okay. So then I'm starting, so in order to do normal form stuff, you have to know two things. You need to know what are the functional dependencies, and you need to know what are the candidate keys. Actually, what you need to know is what is the primary key. Okay? Now, I've already told you what the primary keys are, but you could have gotten them from these dependencies. Okay? These two are so the guest number in conjunction with the date from is a candidate key because it determines the ending date, the hotel number, and the room number. The hotel number and the room number plus the guest number can determine everything else. Okay, same thing with your hotel room number combinations. Given a hotel number, a room number, and a date, you can get all the other information about a tuple. It uniquely identifies the tuple. So it turns out there essentially are 4 candidate keys defined by these 4 functional dependencies. So on an exam, I would probably tell you the primary key because I want it to be consistent, although I might not because I'm able to grade any of those 4. But they would lead to somewhat different decompositions depending on which of these 4 keys you chose to be your primary key. Okay? For an exam, what do you think I would choose the primary key to be? Because the question would be uninteresting if I chose the other one. On an exam, it would be hotel number and room number is going to be your primary key. And the reason is that if I made the primary key be guest number and date from my perspective, it turns it into a boring exam problem because what did I tell you about first and second normal form in this case? Actually, that's not true. They are, guest number is I take it back. There is a partial. I was thinking that with just guest number that it was already in second normal form, but that wasn't quite true. However, let's just say there are more interesting partial dependencies if I make hotel number, room number, and date from be my primary key. Okay, so let's say that I make hotel number, room number, and date from be my primary key. What is going to be my partial dependencies? Let me do something. Makes it easy to make multiple choice questions. Okay, tell me, give me a number. 1, very good. So hotel number, the left side determinant of that functional dependency is a proper subset of my primary key. So 1 is a partial dependency. Give me another one. 4, very good. Room number and hotel number are a proper subset. Anything else? No. But good question, though. So the question was, is a zip code? The answer is no, because the hotel number determines the zip code, and then the zip code determines the city. So the zip code is going to actually end up being a transitive dependency. Okay? So the only ones we have, so I will star them. This one, actually I will put P and P. So those would be used to get us to second normal form. So if I asked what are my second normal form relations, my second normal form relations are going to be, just like, I know I'm going to go a couple minutes over, but this will help a lot on your homework assignment, so just bear with me. So my second normal form relations, I would be using 1 and 4. So 1 is going to lead to the relation, I'll call it hotel, that has hotel number, hotel name, and now the zip, which I'll call hotel zip, or I can just call it actually zip code. And I have to bring along the city. So anytime I have a transitive dependency like I have with zip code, when it moves, you have to bring anything it determines along with it. So not only does zip code move into the hotel relation, but I also bring the hotel city in. Okay? Then number 4, so that's what I get from number 1. From dependency 4, I get, I'll call it the room relation, which is hotel number, room number, determines the room type and the room price. And what I'm left with is the original universal relation, which was the reservations relation, with the right side attributes for the 2 partial dependencies removed. So what I have is reservation with all of the attributes from the functional dependency that involves the primary key. So hotel number, room number, date from, date to, guest number, and then all of the information associated with a guest. So the guest name, the guest city, and the guest zip. And that is what I have for second normal form. Now to go from second normal form to third normal form, I am going to eliminate any transitive dependencies that exist in any of the 3 relations I have that are in second normal form. And if I go back and look at my dependencies, then 2, which is zip code, goes to city, and the third dependency, which is guest number, goes to guest name and zip code, are both transitive dependencies. So I will use those 2 dependencies to further decompose my relations into third normal form. So using dependency 2, I will be taking the zip code determines city out of the hotel and putting it into a separate one. So I'll have hotel, hotel number, hotel name, and zip code. And then zip code will go into its own one. So I'll call them, let's say, zip code. And zip code is the primary key, and city is going to be the dependent attribute. And then for the third one, guest number determines guest name and zip code. This will come out of the reservation relation. So you can see guest number coming out here. So we'll have, we'll call it guest, and it has guest number as a primary key, and then guest name and guest zip as the 2 attributes. And now we've already pulled the guest, we've already pulled out zip code and city in this relation. So we already have the zip code transitive dependency pulled out. And then the remainder of the reservation is hotel number, room number, date from, date to, and the determinant, which was guest number, that does not, that stays, but the guest name, guest city, and guest zip have moved off to the decomposed relations. So we are left with these relations, and nothing happened to the room relation. So it still has hotel number, room number, room type, room price. It was unaffected. It was already in third normal form. So these 5 relations comprise our third normal form relations. And again, 2 reflects the 2 relations we get by decomposing the hotel relation using transitive dependency 2, and the guest and reservation relation down here are the 2 relations we get by decomposing using the third dependency. Now you may wonder what happens with dependencies 5, 6, and 8, and the answer is they're not used in the normalization process, and the reason is they represent, in effect, candidate dependencies. So that brings me to my final point. There's essentially 3 types of dependencies that we have. So you've seen we have partial dependencies, which we use to go from first normal form to second normal form. Then we have transitive dependencies, which we use to go from second normal form to third normal form. And finally, we have what I would call candidate key dependencies. And these are dependencies where the left-hand side determinant is a candidate key. And one of these dependencies will become the primary key, and the remaining ones will not be used in the normalization process. However, it is probable that these candidate key dependencies will end up being preserved in the same relation as the primary key dependency. So if you look up here at the final reservation 1, and then you look up, we go up to the dependencies 5 through 8, it turns out that dependencies 5 through 8 are all preserved in this reservation relation. And remember, the reservation relation is what remains of our initial universal relation. So in fact, in general, these candidate dependencies will all end up being preserved in the original universal relation when it's reduced to third normal form. And remember that one of the things we want to do with normalization is preserve all dependencies. So in general, all candidate dependencies or all candidate functional dependencies will be preserved in the final reduced version of the original universal relation.